Welcome to the section on solving nonlinear systems. I want to start off with a very quick review about solving systems. When we first learned to solve systems, we were given two lines, and you had to determine if they crossed at one point, at infinitely many points, or at no points. And to do that, we used three different types of methods: elimination, substitution, or graphing. And you might have been given two equations that look like this, and you'd have to determine which method was the most efficient, and then you would solve to find what point or points they may cross at. In this example, maybe you would have used substitution by plugging x minus 3 in for the y, and then solving for x and y. Or maybe you want to go ahead and graph and see where they cross. But this is what you first learned when we talked about solving systems. Well, now, because we know of other types of graphs, we can expand what we know from just lines to now lines and other conic shapes. And I've got some examples here of what that might look like. These three different examples are not the only examples, so keep that in mind. These are just random ones that I created, but they show the different types of solutions that you could have. Here we've got an ellipse and a line. Notice that they never cross, so this would be considered no solution because they're never going to intersect. Here we've got hyperbolas and a line, and notice they cross at two places, so that would mean that this has two solutions. And then this example here, we've got a circle and a line where they cross at one point, so this would be a one solution example. And so what we're going to be doing today is using our systems of equations of lines and conics to solve for the intersections. And notice we could have one, none, or two. All right, so let's jump into an example, and then I'll give you one to try on your own, and then we'll get into part 2 of today's video. In our example that we're going to go through together, we've got two equations here. We've got 9x squared plus 25y squared equals 225, and we've got 10y plus 6x equals 6. First, it's always important that you know what kind of conics you're working with. This could help you gauge the types of solutions you could have. Notice that on the bottom equation, we've just got x and y. That means this is going to be a line. And then on this one, we've got a plus and two different numbers, which means that this is going to be an ellipse. And if you're not sure where I got those, just make sure you ask in class. Now we just need to go ahead and determine what's going to be the best approach for solving. I've got three options here: elimination, substitution, or graphing. Graphing is always a good one to go to check your answer. And the one thing I'm going to say about elimination is that in order to use elimination, you want to make sure that your variables are matching. X squared and x are different, and y squared and y are different. Therefore, you can't eliminate them easily. So the easiest approach in this example is going to be the substitution. All right, so let's go ahead and start with substitution. When you're doing substitution, the goal is to get one variable on its own. So I'm going to start with the line, and I'm going to get the y alone. And that means I'm going to have to subtract 6x to the other side. That's going to get us 10y is equal to negative 6x plus 6. Then I need to divide every single thing by 10. And when we do that, we're going to get y is equal to negative 0.6x plus 0.6. All right, and now because I have y is equal to something, I can take that equation, let me get this in red, and I can replace or substitute this into my second equation up at the top here, and that's what I'm about to do. This does take a little bit of space, so just make sure you have room on your notes, but I'm going to take the y out and replace it with this equation, and that's going to give me 9x squared plus 25, then times negative 0.6x plus 0.6, all squared, don't forget that, is equal to 225. Now I need to go ahead and simplify. PEMDAS says do parentheses first, then the exponent part. So I'm going to go ahead and do this portion first, where it's squared, which means I'm going to have to FOIL. Okay, and please remember when you're FOILing that you need to write it twice if you don't remember the little trick. So I'm going to do this up at the top. Whoops. So negative 0.6x plus 0.6 times itself, because there's two of them. So if I FOIL all of that out, then I'm going to get, let's see, 0.32x squared minus 0.72x, and then plus 0.32. So this is just FOILing. I didn't show all the steps, but you should get the same thing. So make sure you try it and that you get the same equation. And that's what's going to go in here. All right, so if I rewrite this, I'm going to have 9x squared plus 25 times 0.32x squared minus 0.72x plus 0.32, and then this is all still going to be equal to 225. And now that I've FOILed and I've gotten rid of that, I have an equation of all x's. So I'm going to go ahead and distribute the 25 to what's in the parentheses, and that should get me a little bit nicer numbers. 9x squared plus 9x squared minus 18x plus 9 is equal to 225. Now, it won't always work out that nice, but this one does. And now I just need to combine like terms. 9x squared plus 9x squared is 18x squared minus 18x plus 9 equals 225. And if you notice, this is a quadratic. There's an x squared and an x term. So what that means is I need to set my equation equal to 0. This should be review at this point of solving quadratics. That's going to get me 18x squared minus 18x minus 216 equals 0. And remember, when we're solving quadratics, we have two options. You could either, let me write this here, factor or use quadratic formula. Okay, and I don't care which one you use. Obviously, factoring is going to be the quicker method if it's factorable, but that's entirely up to you in terms of what method you're comfortable with. I'm going to go ahead and factor. So I'm going to take an 18 out, and that leaves me with x squared minus x minus 12. And if I factor what's in parentheses, what are my factors of negative 12? That will get me a negative 1. Well, that's going to get you negative 4 and a positive 3, because negative 4 plus 3 is negative 1, and negative 4 times 3 is negative 12. And because I've factored it, now I can set each part equal to 0. So I get x equals 4 and x equals negative 3. Now, you don't want to stop there, because remember, when we're solving, we're looking for the intersection points, which means we have to have ordered pairs. So that means that you need to take these x values and plug them back into your original equation. So if I plug them back into this original equation here, let's say I'm starting with the x equals 4, then I'm going to get that y is equal to negative 0.6 times 4 plus 0.6, and that's going to get you that the y value is negative 1.8. So my ordered pair would be 4, negative 1.8. Okay, so that's one answer. And then I'm going to do the same thing with my negative 3. So if I say x is negative 3 and I plug that in, then when I solve, I'm going to get that y is equal to 2.4. So then my second point where these two graphs cross would be at negative 3, 2.4. And then we'd be done. So anytime it's saying solve the system, I don't want just the x value, I want the ordered pair, which means you need to plug your variable back into the original equation. And you could have plugged it into the one I boxed in, which is what I did, or you could have plugged it into either of the original equations. You should still get the same answer. Okay? And graphically, if you wanted to look at this, so I said graphing was typically the easier approach. If you can graph those two equations pretty quickly, then notice they cross at 2 points, and those should be the exact ordered pairs that we got, which they are. So that's a good way to check your work, is work it out algebraically, find the ordered pairs, and then check it with your graph and see if you get the same 2 points. And if you do, then you're good to go. All right, so this one had 2 solutions, and then you're done. Now, this is another example here that I would like you to try if you can. This equation at the top is a line because we've just got y and x, and then here we only have one thing that's squared, which means that this is a parabola. So you have 3 potential options. They could cross 0 times, 1 time, or twice. So my suggestion would be to use substitution. Okay. Solve for a variable, plug it into the second equation, and solve just like I did in example 1. If you have any questions, let me know.